Hello, and welcome to Functions, to Graphs, to Tables, and Equations. In this video, we are going to talk about stuff we're going to do for class in a matching activity, and we're also going to go over the basics of functions, how they relate to graphs, tables, and equations. Before we get into that, I want to talk about the difference between discrete data and continuous data. For the activity that we're going to look at in the next section in the matching activity, we're basically dealing with continuous data. And continuous data means that basically it continues. There's no break in between. And the independent variable that we're going to be dealing with is time. Discrete data, the independent variable doesn't have to be time. In fact, it probably won't be, because it can be broken up into parts to where you can kind of describe it as you can only have partial amounts. For instance, if you were given a graph that looked like this, and on our x-axis was the amount of pennies that you put into a mysterious machine, and this was, let's say, Jolly Ranchers, and say this magical mystery machine allows you to put in, for every 1 penny you put in, you get 5 Jolly Ranchers. So we would plot that data like that. And if you put in 2 pennies, it would give you 10 Jolly Ranchers. Now the reason this is discrete data is because, can you have 7 Jolly Ranchers in this case? It's only intervals of 5, and you can't break it up. So that would be considered discrete data, versus the data that we look at when we talk about continuous data. If this were time on the x-axis, time doesn't stop, and you can always break it into smaller and smaller parts. So if you have data like this, it just means that time is continuing. Now we're going to look at, from the matching activity that we have four scenarios here that we're going to try to describe with a graph, a chart, and equations, or what are called piecemeal functions. So I'm going to look at the one that says D1, and you can look in the right corner, top corner, to tell which description we're talking about. But Garrett waited 3 minutes before starting to fill the bathtub. After 2 minutes of adding water to the tub, he decided to drain the water. So automatically from this description, we know that we're going to be looking at time, because it tells you minutes, and levels of water in a bathtub. Now all the scenarios in our matching activity are going to deal with those two variables. And as you can see, if you read some of the other descriptions, they all relate to time and levels, bathtub levels. So what I want to do is I'm trying to match the description to the graph. The reason I picked these two is I think these two are the easiest to match. So I'm looking at this description of Garrett waiting 3 minutes before starting to fill the bathtub. And then after 2 minutes he's going to add water, and then the water is going to go down. So I want to see a graph that matches that. So let me just start by looking at each graph. And you can see the number of the graph in the top right corner. So this is G4, for instance. Just a note, when you're doing the matching activity, graphs and descriptions are not in identical columns. You have to move all the way to the end to find the graph column. So be careful, don't write the G's in another column. So for instance, this one has, and if you look at the graph, each one of these boxes stands for 1 minute. And if you see that little 20 there, each one of these boxes stands for 20 gallons, I suppose, in the tub. So in this case, we have 1, 2, 3, 4, 5, 6, 7 times 20. This bathtub starts with 140 gallons of water. And then I see that the line starts to go down, then it steadies off. So it starts at 140 gallons, and after 1, 2, 3, 4 seconds, the water stays steady at 1, 2, 3, 4, 80 gallons of water, or 20, 40, 20, 40, 60. And it stays consistent till the end of the time. So does that sound like our graph that relates to Garrett? I can't hear you. Are you going to give me an answer? Nothing, huh? Figures. All right, so I'm going to say no. G4 does not match. So look at D1 and G5. I think that's what that says. G5. So I see that the line of the water is steadily increasing. And it started at 0, but this one doesn't seem like it waited any amount of time. Because if I was waiting for water, it would be flat. Nothing happens. So that one immediately started to fill up and then left it at the same level. Okay, looking at G7, this graph starts up high and it stays flat for a while and then the water starts to drain. I don't think this is a scenario we're talking about. Do you? Do you? Do you? How about you, Morales? That's right. You asked me to call you out in the video. There you are. All right. So our last scenario, it says Garrett waited 3 minutes before starting to fill the bathtub. Guess what? We have 1, 2, 3 minutes of inactivity before anything happens on our graph. Started to fill the bathtub, so as you can see, the water level starts to go up. But after 2 minutes, and yes, this lasts for 2 minutes, before he decides to drain the water level goes back down. So I think I have a match. D1 matches with G9. Now we're matching graphs to tables. And the tables have all these numbers on them. So the way we do this is, remember that you can track each one of these squares counts as 20 gallons of water on the y-axis. And each one of these squares counts for 1 minute. So for instance, this first graph, G4, we count 1, 2, or 20, 40, 60, 80, 100, 120, 140. This graph starts at 140 gallons. So if I'm trying to match up which one this matches up with, it's not T2 and it's not T5. Why? Look at 0. This one starts at 140 and this one starts at 140. So the time is 0. The time, by the way, is our X, independent axis, right? Axis, right there. And then our Y, or f of X, is the level of water in the bathtub. So both of these start at 140. And then what happens in this graph, it goes from 140 and it goes down. And you can see at minute 1, 2, 3, 4, at minute 4 right here, it trails off at exactly 1, 2, 3, 4, 80. So you can see if I was matching up a graph with a table, I could see that 140 goes down to 125, 110, 95, then 80 all the way to the end. So I would say, oops, now I can't read the name of this graph. Let's move this out of the way. I would say that G4 is a match with T1. Just these two match. Alright, but that's not what I'm matching right now. I'm still trying to stick with Garrett in his bathtub. And we decided that G9 was the match for that. So I want to find one where there are zeros for the first 3 minutes. And I see 0 for the first 3 minutes. And then I see that my numbers go 40, 80, 60. So they go up for 2 minutes. And then you see 60, 40, 20, back down to 0. The numbers go down. So I would say that G9 and T8 seem to be a match. I'm sorry, not T8, T5. So what about these yellow cards? These yellow cards don't seem to make sense. That's at least what some students of mine might say. Huh? 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 You know you said it. So let's go back to our graph with Garrett. So we're looking at, what is this, G9. And we're trying to match which of these function rules matches. And you see they're kind of broken up. This kind of looks weird. I see over here we have inequalities, and these are and inequalities. So this one would go from 0, x is somewhere between 0 and 6, then 6 and 10. So that's kind of what it's telling you is the parts of the graph are made up of certain things. And just a general rule, if we want to kind of see how it goes, if there's a positive number with an x, that means the graph is going up. So positive, the graph is going up. It's a positive slope. You see something like this where it just says 80. So if it's a constant, that means the graph is flat. And then I see like this one. See how that's a negative 20. If you have a negative slope, the line will be going down. So it's breaking up into parts of time, and it's telling whether the graph is staying constant, going up, going down, and constant. So going back to Garrett. In his graph, you can see that, oh yeah, I learned about this tool. It's like a laser pointer. How cool is that? In this graph, nothing happens in the beginning. So it's constantly at 0. So I'm looking for a yellow that has a constant of 0 in the beginning. What do you know? I see it. And then this line goes up. So I would be looking for a positive slope. And what do you know? I see 40x minus 120. Now don't worry about the numbers. That has to do with slope and y-intercept, and we'll talk about that later. But what this says is between 3 and 5, so between minute 3 and 5, the line goes up. And what do you know? The line goes up. And then this next with the negative slope means the line goes down. And what do you know? At the end, it's back down to a constant. So yes, we found a match. We know that G9 matches with function number 2. So just as a way to review, and we're going to stick with Garrett's example, since he was description 1. If you remember, the function table that matched with D1 was F2. So see how it says under function, you would write that. And the table was T9. Sorry, not T9. T5, the graph, was graph 9. And this is how you record that. You don't need to write out anything else. You just write the letters. And you're going to try to fill out this entire page. But those of you that bothered to watch the video, if you choose to pause the video now, you may write this down so you have the first one done for you. Did you hit pause? I don't think you did. Lauren, did you hit pause? Yep, I called Lauren out because I figured she would be asking. So there's your first example. Time for a learning check. Alright, so let's talk about all the things we did. Graphs tell stories, and when graphs go up, you have to look at the variables. Graphs go down, look at the variables, and you see how they relate. So for instance, we looked at water level and time in this example. And you got to remember what's the difference between an independent and a dependent variable. The independent variable is located on the x-axis. Dependent variable is on the y. And the movement of the line, if we're talking about a continuous data line graph, the movement of the line tells you a story about what's actually going on in the description. And so that's how, graphs can convey meaning. Of course, this meaning can also be hidden behind numbers in a chart. And we also looked at how there can be equations kind of break up parts of the graph if you can find slope and constant moments. And we'll get into more specific into that in a few chapters from now. Okay, so here's your learning check. Make sure you understand. If you don't, you can always rewind the video, go back. I'm sure some people will be doing the activity and want to look at the video, and that might be helpful, but I won't be there. So I hope you guys can get through this video without me. Really, not through the video, get through the activity without me, because I know it can be challenging, but I think you guys will be able to do it. And good luck. Oh wait, but I have one more slide. Ah! Yes, that's right. I thought I'd save the little baby crying in the clown mask. Look at how funny this is. I thought this picture was hilarious. That is the most creepy clown mask you can wear. And this baby is just crying. But I know you guys wouldn't be crying. You'd love that clown. Maybe that's how I'm going to come to dressed as in class. Well, enjoy. I will see you guys later.